When my quadratic has a number at the start, when I put it into two brackets, I'm going to use that number as well as the letter. Now I know that if I then expanded that, I'd have 45 too much, so I'm going to divide by 45 to compensate. So the n numbers need to multiply to positive 2, but I've multiplied everything by 45, so actually positive 2 times 45 is 90, so I want them to multiply to 90. So 1 times 90, 2 45s, 3 30s, 5 18s, 6 15s and 9 10s. Of those, -5, -18 add up to the -23. Now when I look at my first bracket, I see I've got a common factor of 5, which I'm going to pull out. In my second bracket, I've got a common factor of 9, which I can bring out. Now those two common factors multiply to make the 45 on the bottom. So I'm left with 9f subtract 1 and 5f subtract 2. And if I check, if I multiply the first two, I get 45f squared, and if I multiply the last two, I get positive 2. If I do the inners and the outers, I get -23. Now you may be able to come up with the 9 and -1, 5 and -2 just by trial and error, but this is a method that works every time. So for example, this next one, I could just try different combinations, because to make 6, I could have 6r and r, or I could have 3r and 2r. To make 10, I could have 1 and 10. Well, that clearly doesn't work in that combination. Or I could have 2 and 5. That's not going to work. What about if I use 2 and 5 down here? Well, if I have a -5 and a positive 2, my outers give me -15, my inners give me positive 4, which does give me -11. So that is my answer. Now, that's just by lots of trial and error, doing lots of mental calculations. If you follow the other method, and we have 6r over 6, look for the factors of -60. There's quite a lot of those. But we're keeping our eye out for ones that add up to -11, so I've actually already got there. +4 and -15. Then my first bracket has a common factor of 2, and my second bracket has a common factor of 3, and those common factors cancel with the 6, so I get to the same final answer without having to try lots of different combinations. I've got a system that works every time.